Welcome back to Geometry Chapter 8. This is such a fun section. Section 8.5 is angles of elevation and depression. We're going to solve problems. There are going to be a lot of words, and all you're going to need to do is draw a picture and create a SOHCAHTOA problem. So it's word problems for Section 8.4. So just like I said, every time you are given a word problem, your best option is to draw a picture and label it. Then you don't have to worry about digging information out of a statement or a sentence or a question. It's just all there. Next up, you're going to set up an equation using a trig function. So we're going to see what's on our picture, what do we have, and which part of SOHCAHTOA are we needing to use. Solve, label, word problems. We typically like to label word problems. And last but not least, don't forget that you're going to round angles to the nearest whole and sides to the nearest tenth. So honestly, it is exactly what we were doing, except we have to do a little interpretation first. So let's talk about the two types of angles before we get going. So if I am a person standing up here, here's my eyeball right here, it's purple, and I am looking down at something, right? So here is where my sight line would be, a horizontal line. This is where I'm looking down at this lovely little ladybug. This is my angle of depression. Angle of depression means you're looking down. If I am a ladybug with a lovely blue eyes, and I have, here's where my sight line would be if I were a ladybug, and I am looking up at something and making eye contact. When I'm looking up, that's an angle of elevation, right? Elevation, it kind of makes sense. You take an elevator and you go up. Depression, we always think of feeling down or looking down or, just not feeling great altogether. So angle of depression is when you're looking down at something, and you always use these horizontal lines. So what your sight line would be, and then how many degrees you're looking down. If it's an angle of elevation, you take your 90 degrees and how many degrees you're looking up. So let's start with our angle of elevation. The angle formed between your sight line, that horizontal, or where you're actually looking, and a horizontal line. Remember, angle of elevation, you're looking up at something. So you're looking up at the airplane flying overhead, or you're looking up at somebody on the roof of a building, or whatever it might be. So let's see what a problem looks like. The angle of elevation from point A to the top of a cliff is 34 degrees. If point A is 100 feet from the base of the cliff, how high is the cliff? So let's draw this. The angle of elevation from point A. So here's point A, and I'm looking up at the top of a cliff. I'll call that point C, right? Here is my horizontal line that I would be looking. So this angle right here is 34 degrees. Point A is 1,000 feet from the base of the cliff. I'll call this point B for base. 1,000 feet from point A to the base of the cliff. How high is the cliff? That means that I am wondering, how high is that cliff? The ground and the cliff have to form a 90-degree angle. Remember, we're only using right angles, so you have to create some sort of right angle here. So here is my diagram. Once I've got this diagram, that looks just like what we've been doing previously. I want to know this side right here. I've got this angle, and I had to know elevation meant that I was looking up at the top of the cliff. So if I'm using this angle A at 34 degrees, X is the opposite. 1,000 feet is the adjacent. It's definitely not the hypotenuse. So what part of SOHCAHTOA will I be using here? Opposite and adjacent would be tangent. I didn't write it at the top of the page, but hopefully you've got that figured out. So tangent of the angle, what's the angle? 34 degrees. Opposite over adjacent, opposite is X. and adjacent is 1,000. I'm not looking for an angle, so I don't need to use inverses. So remember, paper and pencil math first, please. If I'm going to solve for this x, I need to multiply by 1,000 on both sides. That crosses these guys out and leaves me with an x. And it means that I go to my calculator and I do 1,000 times the tangent of 34. I end up with, once you go to your calculator, double check and make sure that I've done my math right, 674.5 feet. I should put approximately, right, because I did round that to the nearest tenth since it was a side. And there it is. That's an angle of elevation problem. Easy peasy. So let's go over to an angle of depression. Oh, I got a lot. So angles of depression are the angles formed between your line of sight where you're looking and a horizontal line when you're looking down. So think about the guy looking down at the ladybug, right? He's looking down at that. That's an angle of depression. Here's the thing. Angles of depression have a little sneaky extra step. You'll get the hang of it. But we will need to look at parallel lines and use some alt interior angles. All right, so let's look at this problem over here. So an angle of depression from the top of an 80-foot building to point C on the ground is 42 degrees. Okay, so let's see, I've got an 80-foot building. That was easy to put in there. And the angle of depression, so I'm on the top of the building looking down at point C. So something like this, right? This would be point C. I'm just going to put this. I know I'm going to have a right triangle in here. Here's the thing. Here's the tricky part. The angle of depression is when I'm at the top of this building looking down. So I use a horizontal line. This, looking down, is 42 degrees. Angles of depression, you have to really be watching. Well, doesn't this horizontal line right here and this horizontal line down here, the ground, have to be parallel to each other? So therefore, I'm not inside the triangle, but if this guy is 42 and this line right here is my transversal, that means that this angle has to be congruent to this angle. So this angle down here is 42 degrees. Don't try to be sneaky and say that this is 42 degrees because this has to be 90, right? That doesn't even make sense. You could figure out that other angle, but do not try to put that 42 on the top angle of your triangle. That goes down at the base. So 42, I used parallel lines with that dotted horizontal and the bottom, the ground, and I used alternate interiors to put the 42 inside the triangle. Okay, so let's see, I've got my angle of depression in there. I know it's an 80-foot building. And how far is the foot of the building from point C? So the foot of the building would be the bottom, right? Our feet are on the bottom unless we're doing a handstand to point C. So this would be my X right here. So if I'm using 42 degrees, 80 would be the opposite. X would be the adjacent. So I can easily fill myself up a little trig function. What trig function uses opposites and adjacents? So tangent of an angle equals opposite over adjacent. So my angle is 42. My opposite is 80 over the adjacent is x. Now, if you were a really sneaky person, you probably could find that other acute angle, and then you wouldn't have x in the denominator. But we've done this. So there's a couple ways you can do this. I'm going to do this the technical way. To get rid of an x in the denominator, I have to multiply by x. That crosses these guys out. So I'm left with x times the tangent of 42 equals 80. Well, to get that x by itself, all I need to do is divide by the tangent of 42. So when I go to my calculator, this is my paper and pencil work. When I go to my calculator, I'm going to type in 80 divided by the tangent of 42, and x is going to be approximately 88.8 feet. Round to the nearest tenth. Again, I may have taught you a different trick on how to solve for x there or a shortcut, but that's the technical way just in case. All right, so that's our angle of depression. Angle of elevation, easy peasy. Angle of depression has that extra little step. Make sure you're putting your angle in the right place in the triangle because it actually starts outside of your right triangle. All right, so let's see. I feel like we should do one more. Let's do example 6. A ski run is 2,000 yards long and has a vertical drop of 425 feet. What's the angle of depression of the ski run? I don't know if any of you have gone skiing, but let's say here is my right triangle. It says that the ski run itself, where would you ski? What part of this right triangle would you be on? Right, that would be the slant. So this would be 2,000 yards. It has a vertical drop. Here's your clue word. Vertical is up and down, right? So this has to be 425 yards. What is the angle of depression? Well, depression means I'm up high looking down. So I'm asking, what is this angle right here? So just like that last problem that we did, we have to be careful. That's not inside my triangle. However, I could do an alternate interior, and this is the same as my angle of depression. So here's my angle that I'm working with. This time I've got opposite 425 and the hypotenuse. So which trig function is opposites over hypotenuse? That's going to be sine, right? So sine of an angle equals opposite over hypotenuse, and that angle is our unknown, so we can put an x or an a or a whatever variable you want. So we're looking for an angle. So remember how we find an angle, 8,4c. The only way to separate an x from a sine is to do an inverse sine, but I have to inverse sine both sides. So paper and pencil math tells me I've got inverse sine of 425 over 2,000. When I do that math, I'm going to figure out what the angle is, rounding to the nearest whole degree, because that's what we do for degrees. I've got about a 12-degree angle of depression. If I were at the bottom of the ski hill looking up, this would be my angle of elevation. If this were me right here, looking up at the top, I'd have a 12-degree angle of elevation. So just be careful how you set those guys up. So again, this is just a rerun of section 8.4 using all of our SOHCAHTOA skills, but we've got word problems. Draw the triangles. They're always right. That's it for section 8.5. Have a great day.